Hello and welcome to the UAA College of Engineering Capstone Poster Competition. The format of today's professional development seminar series presentation will be a lot different because we're going to be going through basically a public space and just trying to capture the 30-second to a minute description of the posters from each of our contestants here. So the goal here is to get started right behind the judges, and so if you'll bear with us, we will get started here in a few seconds. First group, and take it away.
So for our project, we were assigned with Bird Wings of Alaska. They're a little startup company here in Anchorage. I think it's just one lady running it. Her name's Amy, but she makes these chocolate bars that are about like I don't know this big. Sorry, I can't really describe the dimensions. But so our task was to build a machine that would wrap those chocolate bars, because like currently they're being wrapped by hand, like each individually, and that takes a lot of time. And so our machine is supposed to increase the efficiency of wrapping the chocolate bars. We were guessing about 300% increase in efficiency, hopefully. But anyway, here's our what we came up with. We actually have a 3D printed prototype, but we're going to be bringing that to the presentations later at 1 p.m. today. It didn't work out as well as we were hoping to, but if you were to automate this and like basically make multiple of these and like string them together so that they work in tandem, you could even wrap multiple chocolate bars at a time. So that's kind of the idea, like for possible future projects. But yes, it's a channel design. So here's like the main component of our machine right here. So the chocolate bar gets placed in this channel, and then all the arms do all the folding motions. So the chocolate bar gets placed in there with the wrapping paper, and then the arms do all the motions to wrap it. And there's like, 4 levers, and so and one of the levers does 2 different motions. So there's 5 motions in total. Each of them move linearly, and so we're thinking probably about 9 or 10 seconds to wrap one chocolate bar with this machine. Yeah, that's our project.
Awesome, thank you very much. All right, looks really good, thank you. All right.
Oh,
What?
is it through Zoom or?
YouTube Live.
Let's see. Okay.
Are we just like running through it?
Yeah, just run through
Hello. Okay, so as hairstyles are currently changing over time, modern tools that exist to style hair are hair dryer diffusers and curling irons. And from our research, we found that those two products are really damaging to hair as they use super high temperatures. So our client came to us with this prototype.
And with the from the course of the project, our goal was to optimize this design and get it to work as good as possible and address issues with curling irons and diffusers. So the first method we used to do those changes was user feedback because it's a consumer product. So what we did is over the course of the project, we gave the design to different people, to users to test it, and then we got survey results from them through survey questions, and whatever scored the lowest in categories, we adjusted the design accordingly. So this is our newer one, and you can see it's much smoother to help with just the ease of use and just the general liking of it. And also, curl time was the lowest one. So what we wanted to do is make it hotter when you use it. And this graph shows we did with the new model, we reduced the number of holes overall to achieve a higher temperature. In this graph, through the two blue lines right here, shows how much hotter that this one was compared to the old one. So we achieved a higher temperature and reduced the curling time.
For our theoretical calculations, we use transient heat transfer to make sure that the outer surface, while you're using the product, as you're using it, you insert hair into it and twist while directing a hair dryer into it to curl hair. So we needed to make sure that the outside temperature stayed below a temperature that would cause pain to the skin. So for our cost analysis through manufacturing, we found through quotes from injection molding companies that the price of a mold base would be around $20,000 with a price of $4 per part. And we also found that through 3D printing, it would cost around $15 per part. So to justify injection molding, she would have to produce around 1,900 products. So for our conclusion, after contacting companies, we found that polypropylene would provide the best qualities for this product, as it would work well with wet hair and in high temperatures. And our client was super happy with the outcome of our product. So thank you.
Awesome. Thank you very much.
Sure, yeah. Okay, so our presentation was a kelp drying feasibility report. It includes myself, Caleb, with Ben, Wes, and Mikhail. So we were approached by Regenerative North to help make their high tunnel in Homer more beneficial for the kelp drying process. They gave us a little bit of data last year that included dry times between 20 and 40 hours. They wanted to reduce that. So some main things that we did was we started with a flow distribution right here. It shows with the we decided to do 3 fans and move where they are placed, and then include some hangers. So you can see the heat went up to about 120 degrees from 98 that they had last year. And Mikhail did more of the CFD, so I'm going to pass that on to him.
Yeah, so from the data that they had from last season, which wasn't a whole lot, we were able to actually get increase their temperature from 98 degrees to 120 degrees, and that was with assumptions from the heat, the energy from the sun, and the temperature and humidity data from the Homer area. We also looked into capturing waste heat off of a nearby freezer. That was something that they wanted us to look into, and we found that from that compressor in the freezer, you would only get about 1.08 kilowatts per hour of heat rejected from that, which isn't quite enough to heat up an entire 24-foot by 20-foot high tunnel. So we said that we recommended not to go with that route as a heating option. But if Wes, do you want to go on a little bit about the HRV?
Sure. Yeah, and we did some research into heat recovery ventilation units and energy recovery ventilation units. Determined that a heat recovery ventilation unit is the most appropriate choice for northern climates and would be best applicable for this model in the high tunnel. Utilizing a heat recovery ventilation units allows them to have the appropriate amount of air changes rated for the space, so you're bringing in fresh air into the space, changing out that air through one of the exhaust ports that they have available in the high tunnel, and meeting the ASHRAE standards. And then we were also able to go ahead and spec out the appropriate dehumidification unit based upon the size of the high tunnel. They had previously been utilizing a home use dehumidification unit, and just with the smaller rated unit, they were viewing a reduction in 2 to 4 hours of their kelp processing time. So going into 2023, we also have a recommendation for them to purchase and install some humidity and temperature sensors so we can model data further, and this can be progressed further going into the future. Thanks.
No, I think we're good.
Yeah. Come on over here. Hello. We're good? Okay. So my name is Tremaine Booker, and my partner here is...
I'm Jared Vitug.
And our project was a website called WikiConnect, which is a way to visualize Wikipedia's network and offer some insight to its analysis. So Wikipedia can be viewed as a network if you take the articles as nodes and the hyperlinks that go to other articles as the edges. So you can see here, there's like the NFL 1921 season, and it connects over to 1921 Green Bay Packers season. Connects those two articles. And most of this front end webpage, nice looking stuff was made by my partner here. So I'm gonna go ahead and give it to him.
Hi. So a lot of the basic website stuff was done using your standard like HTML, CSS, JavaScript, but like the actual bulk of our visualization was done by a JavaScript plugin called Cytoscape.js, which lets you enter in various kinds of data and then basically manipulate it and format it how you want, which is what we did here. So in our case, we chose to represent our data as cola graphs, which are force-directed graphs, and yeah.
Yeah, and that's how the front end was built, but I handled the back end, and so that was a lot of collecting data, downloading all of the article titles and their links between them, and saving that, and then loading that into a network and analyzing that network. Unfortunately, we could not fit the entirety of Wikipedia into memory. Unsurprisingly, Wikipedia is huge, and to fit all of it, it would take upwards of 1 terabyte of RAM, and we did not have access to that. But we did fit 2 pretty sizable subsections, one of them being 1,600,000 articles, the other one being 1 million. And we did some analysis, and there's a bunch of specific data points. But overall, the biggest conclusion is that Wikipedia is not a very connected article or connected network. Getting from one node to another is pretty difficult, and you typically would have to go through one of these central nodes to get there and do any efficient movement. Yeah, and so we were initially planning to have this whole network fit into memory. We underestimated how big it was going to be. And if we were able to do that, we could fit in a couple extra functions, such as like a shortest path finder, trying to find the shortest path between any 2 articles, as well as like a little mini game to interact with that. Yeah, that's all.
Thank you very much.
Thank you.
Awesome.
Oh, I'm taking it? Is this going straight to... Oh, I see it now. All right, cool. Ready for me? All right. Hey, good morning, everyone. Welcome to Hand Drawn Hero. My name is James. This is David. So pretty much what we created was a 2D video game, top-down action adventure, very similar and akin to the original Legend of Zelda games. So in order to do that, we started off using the Unreal Engine. We used the newest version that was available at the time that was released in April of 2022, which is Unreal Engine 5.1. We utilized blueprints, pixel 2D, tile sets and tile maps, your traditional game development stuff. A little bit difficult creating a 2D game in a 3D engine, but we did make it happen.
Well, so the development of this game is kind of interesting. It dates back to about a year ago when I was doing it with some other people, that being Austin Edwards and William Spear. We originally wanted to make a roguelike game, and this project kind of carried over to this semester's Capstone project, and I decided to change the genre because I felt like there was too many roguelikes in the market, so I decided to go a little backwards and do basically just a Zelda clone. As James said earlier, we use Unreal Engine. Specifically, I guess I want to talk about more about the sprite animation state machines and the behavior trees. Animation state machines are basically what they sound like. There's transitions, mostly a Boolean, or if this is less than the other thing, which will determine what direction the character is going. This also applies to enemies. There's also not blueprints. I'm sorry, state machines within state machines that will go over different actions. And then the other thing is the boss behavior trees, which is basically just it's like AI, but not really, because it's a gamer term. But basically just a bunch of tasks, just a bunch of variables that makes it make decisions. But what we got done was basically just one level and a boss fight. But yeah. Yeah, sure.
Absolutely.
I'll show them.
Absolutely.
Give me the controller.
So the gameplay is pretty self-explanatory. I feel that I don't need to narrate it.
You run around as our little night guy. I don't even know. Hold the mic closer to me so I can talk about it.
Here, I'll go around. There we go.
But yeah. My brother actually helped me draw this. His name is Alexander Mitchell. I don't have any social media, sorry, but look him up. Yeah, he helped me draw a lot of these stuff. I had to draw a little bit of it, but yeah, the idea was that this game takes place in an angsty teenager's notebook, and it was kind of like it's just the world that he drew himself, this kid or whatever. But yeah, it's
Well, very cool. Thank you very much.
But yeah.
Thank you.
Really enjoyed it.
All right, so the goal of our project was to determine risk factors for Alaskan crashes, and we looked at driver, environmental, temporal, and roadway risk factors. And we had three main research questions. What are the risk factors for injury? When is each type of crash likely to occur? And then, are there factors beyond our original data that could be impacting crash rates? And so here you can see the data that we used as risk factors. I'm not going to go through all of it. But so for our first research question, we were looking at risk factors for injury in crashes. And to answer this, we got 4 models, trained 4 machine learning models. And the models found that these were the risk factors for injury. These were the ones they selected. Type of crash, road conditions, time of day. And our key takeaway for this research question was crashes that occur on icy and snowy roads are less likely to result in injury than crashes on dry roads. And then our second research question was the likeliness of each crash type occurring. So for this, we compared 2 crash types. Non-collision, which is where the vehicle does not collide with another object, and then collision with an animal, pedestrian, or cyclist. We trained 2 models on this, and this is our XGBoost model. And what this model is saying is that a collision with a pedestrian, animal, or cyclist is most likely to happen when the roads are dry and the driver is 30 or older. And then on the flip side, a non-collision is most likely to happen when the driver is younger, so below 31. We have a typo here. And the roads are not dry.
Yeah, and for our third question, we basically wanted to see if there were any factors beyond our data set that could impact crashes. And we mainly focused on solar altitude here. So basically what we did was we calculated the solar altitude using the latitude and longitude from each crash. And then we were able to calculate the baseline solar altitudes during each month in Anchorage. And then we used those to calculate like the solar altitude, the number of crashes compared to the baseline. And as you can see, our key takeaway was that solar altitude was actually highly correlated with crash rates. and then most crashes occurred at twilight or 0 degrees and between 0 degrees and 9 degrees. And then we also developed a website that users could use to utilize all these machine learning models that we developed. And basically what they would do is the user could select a dependent variable, and then they would select independent variables, and the code would build the model and output the results to the user. And future research we want to do is we want to expand our data set to see what else could be affecting crashes a lot. And then we also want to compare crash rates in urban and rural areas to see if that has any correlation to crash rates.
And we also want to give a shout out to our advisors, Dr. Vinod Vasudevan and Dr. Sean Butler. They were a lot of help on this project.
Awesome. All right. Thank you very much. It's very cool.
Hello, my name is Paul Natcher, and this is Kivagail Ketchum, and our project today is engineering on display. And what we wanted to do was, in EIB, there's a couple of sensors set up by Siemens to automate gathering data, and we wanted a way to kind of deliver that to non-technical people in the front end. And what we also wanted to do was not compete with screen space with the many different screens in EIB. So we also wanted to integrate a way to display images that have announcements or different events that the College of Engineering has. So our implementation was almost to our minimum viable product. We have some kinks working out, and basically we're missing a couple of our requirements, such as user authentication and touchscreen interactivity. And that was one thing that Professor Mock, our faculty, was asking for, but unfortunately we weren't able to implement it. For the most part, our project is working in terms of functionality, but in terms of bugs and visuals, it's still lacking a little bit. And we also wanted to mention that our automation wasn't hooked up, and Siemens is currently not sending data, and we're using data from 2018, actually. So hopefully we hear back from Siemens, but due to our shortened timeline, we weren't able to kind of get that set up properly. And yeah, we basically have graphs set up, and we also have a way to modify the order of the images that you wanted to show on the screen. And we also wanted to implement the duration, but then again, we weren't able to implement that. So as you can see right here, you can edit the different positions of the images. And then when you click this button, it should show you. But however, our current build right now is broken, and we weren't getting data from the database, but sometimes it works, sometimes it doesn't. It's just working out a couple of kinks. So yeah. We want to acknowledge Professor Mock as well for helping us set up and talk to different people so we can get everything set up as well. So thank you very much.
That was very cool, though. I like the way the graphs were drawn.
Yeah. We're using a couple packages. We're using React as our main front-end framework, and React is very popular and has a lot of packages that help with many different things. And one of them was using this charting program, and allows us to kind of dynamically, or has cool animation, but also so we don't have to code up a charting program basically on ourselves. That will take another whole capstone semester as well. So, all right, thank you.
Thank you so much.
Yes, sir.
Hey everyone, at the College of Engineering, my name is Jared Vaughn,
My name is Boro.
and this is actually our senior Capstone project, the Arctic Spark Initiative, working with the U.S. Air Force and the the Ted Stevens Arctic Research Institute. And Boro would like to tell you just a little bit about it.
All right. So main purpose of the project is to monitor and modulate the temperature inside the container, which is supposed to contain the temperature-sensitive medication and medical supplies in a harsh environments like Arctic. And then we managed to build the sensor, and a sensor that can sense the temperature inside the box, and also it can communicate with the heater, and then if the temperature is too low, it's going to heat up the heater. So we managed to build this technology.
As my partner Boro said, using Boolean technologies, we essentially work with individual heaters for different thermal zones. If they are identified outside of bounds of whatever the user would designate as the minimum temperature threshold, it would activate the heater, which the camera is a little far away, but given that we've placed the demo heater in ice, it should within a few seconds actually activate the demo heater and heat that designated zone. In working with the U.S. Air Force, unfortunately, we actually did have to provide a lot of our own material, a lot of our own sort of ingenuity, in the sense that we're both coders and we do not normally work with hardware. There were a lot of obstacles to overcome, but we did enjoy the opportunity to work on the project, and there is a long way to go in terms of establishing a viable final product for the U.S. Air Force and the United States military.
And then also for the software, we built really simple, user-friendly app, and then it's actually Bluetooth-based app, and considering the security and privacy in Air Force, we didn't push into App Store yet, and then it's only Android app, and then we can't actually show you the app, unfortunately. And so if we heat up the sensor, it's gonna if it's gonna reach the buffer heat, it will turn off the heater and then turn off everything off. So this is how it works.
Thank you, everyone.
Thank you very much.
Hi, I'm Austin, and I'm with Connor and John. And for our senior project, we did a website called the Schedule Conflict Checker. And what this basically is a tool for professors or department chairs to schedule classes for the next semester while automatically detecting conflicts. So the way we populate our data in our calendar is you have two options. You can either automatically scrape the data from Curic, which is the proposed data for the next semester website that professors normally use, but it doesn't have a built-in calendar, or you can upload an Excel sheet.
Yeah, and then so we have a few filtering options here. You can filter by courses. You can say, hey, these two courses should never conflict. And then you can specify conflicts within a course range, and then you can ignore conflicts for specific subjects. And then on the right side, we have calendar filtering. You can select instructors that you would like to populate on the calendar. You can select buildings to display so that you don't get all the buildings. You can do the same for the room numbers. And then you can hide subjects from the calendar, and you can hide individual courses from the calendar.
So the data gets imported onto the calendar with the courses. Immediately, if there's any sort of conflicts that are detected, it'll list it in this detected conflicts box and then also highlight it in red. When you select the individual conflict, it'll highlight the entire block in red to show you which classes specifically are being conflicted with each other. Once you determine these conflicts, you have a couple of different options. If you select the course specifically, you can edit that course information, and then the calendar also has drag and drop functionality to where you can move it to different time slots or different days, and then once it's dropped, it'll recheck for the detected conflicts, and if it's out of that conflict range, it'll remove them or update them. So yeah, that's how it works.
Thank you very much.
So our project is the Community Energy Awareness application, and this project was made in partnership with Alaska Center for Energy and Power and Kotzebue Electric Association. It's a web application that kind of acts as a dashboard to convey important and relevant information to the community of Kotzebue. We have 4 main features to it. The first one is a generation breakdown, and that shows us where the current sources for the electricity are coming from, so diesel, wind, or solar. And then our second feature is the community energy or electricity usage. So for the entire community, we have a heat map. So the darker colors represent higher usage, and the lighter colors represent lighter usage.
Then we have the diesel saving feature, which shows how much the community is saving each year. So it's a running total of how much they displaces non-renewables with renewables. And this is money that goes towards the community in development in other areas. And we have the excess renewable energy that gets generated is stored in a lithium-ion battery, and here you can see the state of the battery, if it's charging, discharging, or if it's idle. Yeah.
Thank you.
Our spiel. Yeah, certainly. Hello, everybody. This is our automated plant nursery and greenhouse. So the problem we were looking to solve was starting plants in Alaska early enough to allow them plenty of time to grow, but also not being time consuming when it comes to watering, making sure the environment's good. So we wanted to automate all of the gardener's job, essentially. And the way that we did that, well, I'll hand this over to my friend Sean to talk about the hardware.
So this is all essentially run out of this box right here. This box has a Raspberry Pi in it, which essentially does almost everything for the hardware side of the project. The Raspberry Pi will host a Django website, which we have serves to the internet, and it also reads in input data from several temperature sensors and a humidity sensor, and then uses that input to then fire off outputs that it needs to change this. So say we have it's too hot in the greenhouse, it's like 90 degrees. We need to turn it down a bit. So we just turn off our heaters using the Raspberry Pi. The Raspberry Pi senses that it's too hot using a set point on our website, and it will simply turn off the heaters. If it is too humid, we will turn on a vent in the back that pushes air out of the back. And we have a fan that is constantly on to help the seedlings stay strong and to vent air throughout the greenhouse.
Yeah, and in order to allow the user control of this, we developed a user interface using a web application. So like you said, the website gets served directly from this box, and the user is able to then log into this website, as long as they have credentials, of course, so don't try changing my greenhouse. But you can click on change set point, make an adjustment, that gets uploaded into the database, and then the Raspberry Pi will now use that for its controls. So you can also set watering schedules, start times, duration, all that. And in the springtime, it also controls the watering schedule for the garden and the greenhouse.
Very good. Thank you so much. That's very cool. Whenever you're ready.
What time is it? Good afternoon. Good afternoon, everyone. My name is Catherine, and I have Ryan with me. Our project this semester was the Glen Highway Fort Richardson interchange redesign. Basically, what we have here is a confusing three-way stop sign, and so to work with this, we proposed a roundabout, 5-leg roundabout. If you don't know where this is, it's after the Muldoon exit, after the Arctic exit, actually. And so the Fort Richardson Road comes from Arctic, and then here's the off-ramp from the Glen Highway. We have Bear Run Lane that works with J Bear. We have D Street, and this street goes up to the J Bear Gate, and then we have the on-ramp back to the Glen Highway. So what we looked at for the design criteria for this bridge was basically vehicles that come from J Bear that need to get to Bear Run Lane. So like a WB 67. Some basic facts about our roundabout. It has 12 feet. Lane width is 12 feet, and then the inner inscribed center diameter is 120 feet. From our roundabout design, we then moved into our pavement design. We took the data from the Muldoon exit because there wasn't any borehole data with our exit, and so what we had is a 3-inch hot mixed asphalt along with the 3-inch aggregate base and then a 24-inch type A material. From there, we did our project estimate with an engineering cost estimate being around 3.5 million if they move forward with the project, but our overall budget for the project came out to be around 61,000 for the work that we did. So, in conclusion, our roundabout will hopefully help this confusing stop sign at the interchange.
Thank you very much.
Thank you.
Hello, so we are doing the Campbell Creek Trail Crossing at Lake Otis Parkway. Our project here was to evaluate 7 different alternatives that were provided to us by the Alaska Department of Transportation. Here at the bottom of this poster, you'll see that 4 of our alternatives are in solid color. These are bridges. Over here, these 3 alternatives are hash marked, and these are all tunnels. In our evaluation process, we wanted to determine a grade-separated crossing over Lake Otis Parkway just south of Tudor. So we were stuck with either a tunnel or a bridge. We decided to go with a bridge because tunnels in this particular area, the water level is within 8 feet of the surface, which immediately eliminates them as a low-cost alternative. Right here, Campbell Creek Trail is one of the oldest trails in the Anchorage Trail system. Along Lake Otis, there's a specific break. This break we propose to cross with a 230-foot steel bridge. We would tie into the existing trail system on the west side, go up across an adjacent property owned by St. Mary's Episcopal Church, down to this point where our bridge begins. This is currently a single-family dwelling, which at this point would have to be purchased. Cross the road with that bridge, and then tie back into the existing trail system. Overall, this project we expect to cost about $5.5 million, and it has strong community support. The members of the church here have been looking at this crossing for 22 years and like all the benefits of the extra use by trail users, any noise, and in fact, if there's actually usage by unhoused individuals, they see that as a bonus. Because at this point in the last year, they've managed to rehouse 11 families and individuals that have taken up temporary residence in their woods. And the more access they have to those individuals, the better. So this has strong community support, and it's a project that should be done very soon. Thank you.
Awesome. Thank you so much.
Oh, I got like a cool mic and everything. It's on too. Okay, we're good to go. All right, ready? 3, 2, 1. Hello, everyone. So this is the Girdwood Station Improvements Project. So currently the facility right now really is not up to present times. There's only one real shelter that holds like about 3 or so for people, and there's no bathrooms in the general facility. And with this project, we're essentially expanding on this station due to the inclusion of the sewer interchange that's coming in by DOT itself. So we'll have essentially we have a lot of tour buses that are coming into this station. About 8,000 for the summer months is about how many people are coming in, and it's currently increasing. So what we're doing to improve, we're essentially just improving this. And the DOT interchange is going to bring in some of these tour buses from like Alyeska, Girdwood, so on and so forth, into the interchange onto Toadstool Drive, into the actual station itself. When you get into the station, we have a 1,000-foot platform that's level. We have 2 bathrooms on each end of the platform, 2 shelters and a ticket booth. We also have a connection to the Bird Grid Trail that goes directly to the platform itself. And it has around 42 parking spots, for them being ADA compliant, as well as 2 EV stations, if you have a Tesla or any EV compliant vehicles. We also have a new improved railroad maintenance facility for their avalanche program. They do a lot of avalanche, stuff, essentially, mitigation, so on and so forth. And with this improvement, we also have an addition of a gauntlet track. This gauntlet track will put the trains closer to the platform, as well as making the general main line accessible for cargo, so on and so forth. So the tour buses, going through here, this 2-way street, they'll be turning around at the end here and going through back into Toadstool Drive into the interchange to either go to Alyeska or somewhere in Girdwood.
And we also left quite a bit of room for expansion here. So hopefully in the future we can have a commuter train going to Anchorage from Girdwood. People can park their car here, and also people can come from Anchorage to Girdwood Station, park their car, get on a shuttle, and go ski at Alyeska. So that's kind of the dream for this project.
Awesome. Very good. Thank you so much.
Thank you. All right, we are the Big Eddy Facility Projects. My name is Tommy, and with me are Cassie and Jacob. And the Big Eddy facility is located in Soldotna, Alaska. It's approximately located on River Mile 16.5. Our project this semester was to add a parking lot which contained 30 stalls due to the spillage that was occurring at the existing conditions into the roadway. Speaking of the roadway, we also needed to repave the part of the road that Alaska State Parks has owned. The existing walkway currently contains a floating boat dock and one section of the walkway that leads into the riverbank. Our project was then to get rid of that existing walkway and now add a new installation that allows for anglers to continue to access along the riverbank at multiple locations. Due to the existing walkway, we also needed to counteract some riverbank erosion, so we added a section of riverbank restoration, which was accomplished through root wad revetment.
Am I supposed to keep? My name is Jacob, and I concur entirely with everything that Tommy just said.
Thank you very much. Awesome. We hit all 15 posters for the event today, so thank you very much for tuning in and have a great weekend.